My channel is Space Remote Sensing and GIS. So today we will discuss about a very interesting topic, that is raster based change detection technique. In my previous lecture also I showed you different technique to extract the information from the raster using the raster change detection tools. So this is also the same kind of analysis only, okay, but in this case we are directly extracting our target informations, okay. So how will, just like the last time also I did over the so many videos I make in different flood analysis over the SAR and multispectral. So this is also a kind of same technique. So if you see, the change detection is a play a important role for the modern society, okay. So the ability of the detect, measure the changes and visual resources for the both the decision makers and stakeholders is very important. So in this lesson we will actually see how the change detections between the two raster using a different method will help us to identifying the different informations. Okay, so as we let's go to this particular image. So if you see here, these are two image I have. One is this is a pre-flood image and this one is the post-flood image. Okay, so this is a two different image you can found over here. Okay, so one is pre-flood and another one is the post-flood. Okay, so these are two images which we have together. Okay, so one post-flood and pre-flood. So this is the two images which I have with me. Now we will going to see how the change detection analysis tool help us to identifying this the changes. So before I am going to do that, there is a very common technique, like as we know, like we have to do the atmospheric corrections over the both the images. Okay, as as this is basically doing some study over the flood, so maybe the chances of atmosphere effect, so that we will do using the top of atmosphere corrections. Basically that is the apparent reflectance collection. So this is the pre and post image. So we will going to create a newly doing the atmosphere correction. So select it, go to the imagery, come to the raster function, okay, and you need to search apparent reflectance. Okay, so take it, give the input of your first image. The first image is your post flood image. So this is your post flood image. So convert it in albedo, okay, and then simply click as a new layer. So this is your pre-flood atmosphere corrected image. So you can give a name as post flood. Flood by, okay. So the name was changed, okay. So you can now remove this one which is not required. So now the same way you need to calculate the pre-flood also. So for that you need to go to this upon reflectance, give input of this image, click in albedo to convert in 0 to 1 value, and then simply click on new layer. So now this two images which created, so I can give this name as a pre-flood image. So this will be my pre-flood. Okay. So post-flood and the pre-flood both are atmospheric corrected now. So now we can extract the informations from this. So for that I'm just going to use the tool, that is the change detection tool. If you see here, we have the change detection wizard. So in this case I am just going to do the pixel based technique only. So you just see here three different technique is there: pixel based, spectral changes, okay, as well as we have the time series change detection technique. So there is a three different techniques usually we found over this type of images, okay. So which are capability to classify the image in a different analysis when we are actually trying to do, okay. So that's what we are actually doing with. So now if I want to do the analysis, now I'm going for the pixel based change only. So only thing is we have to select the proper way from raster and the true raster. So in from raster, I will just going to need to select it, that is pre-flood image, and the to raster. Okay, we need to select apparent reflectance calculated means TOA corrected. Okay, flooded image. So the post flood. Okay, so that's what I selected. Now you need to go to the next. So in next is a very important steps here where we are calculating the band differences. So in this case, band differences, there is a different techniques are there. So we are going to focus over the indices technique, not the single band difference. I'm going with the band index differences. So once we come to the band index differences, so all the type of indexes which you see here, so that will be listed here also. Okay, so whatever your target you want to do, okay, so simply you need to select it here. So as we targeted the water, so I'm just going to select here as a MNDW. Okay, so see, by default, as we are selecting the MTL or txt file, so by default all this work will go in automation mode. So raster product file selections is very important here. Okay, so now this is a MNDWI, green band and short event parameter, so it is selected properly. Now you just need to click on the next. Okay, so next we will actually look at the preview wizard. Okay, so to results the determining the meaningful changes, the threshold, okay, the particular thresholds that I want to see. So we will use this information to configure the classification outputs, which I am going to do. So for that, what we will do, we can create a statistics over here. So you need to click on this compute statistics histogram. Okay, so you see here it's a potential things will come. So if you want to see the average, okay, so you can come to the source and you can see the statistics. Okay, so you can get the idea about minimum, maximum, okay, and standard deviation. So from checking the minimum value and maximum value, which you need to give it in your classes. Okay, and in case you can make a two group. Okay, one is you can say the non-water, and one is I will make it as a water. So that if I want to do the categorize, okay, so I have to add this value over there. So what is the range is coming, so that value I have to give accordingly to pick up this information. So I can consider, okay, so 0.3335 is their value. So I can say, okay, the half of this may be 0.67. So I can consider this particular range 0.52 to 0.67 or 66. Okay, so that is as a non-water. Okay, so I will put no color over there. And what is my target body is, that is 0.68 to 1.49, that is my water body. Okay, so if you see the value is coming between this only. Oh yeah, you see 0.88. So I can target this value and extract. So to doing this, best way is you can click on this particular generate tool. Okay, so here the minimum value it is taken 1. So what is the maximum value I just try to give in, that is a 2 suppose. So I will just go here and I can simply select the 2 and simply click on OK. So now here you can give the value range which you want to give. So here I am just trying to give the value is minus 0.36 tab, okay, 0.67, enter. Okay, so this is the first value range, and then second value range which I given it here, that is this one. Okay, so that is 0.68. Okay, and this is 1.41. Okay, so this is the value I'm just targeting. Okay, so this is the high value 0.40. We can take it as 0.41, and see it is perfectly taken the all the values. So only thing is you just need to make it as a no color here. Okay, I just put it over no color, and if you want to give this as a blue, so you can give this as a, so that's all. So if you want to generate this as output, so you need to click on the next. Okay, so we'll do the change direction only and simply click on run. So once you run, you will get the classified image. Okay, so you just see direct image I got the classified. Okay, so one single tool, okay, can make a differences from your image, immediately identifying the water that is tagged during the flood, and it is giving you the results over the multispectral. Just like last week we discussed about the SAR and combinations of the GS Pro. Okay, so if you want to do the analysis for the flood, so how we'll do, So this is the another techniques where you can do the flood analysis. So I hope this video is giving you some idea about this change analysis tool, which is a very powerful tool to do different kind of analysis. So if you like this video, please subscribe my channel and share this video with others. So next week we'll come with the another exciting video. Thank you very much all.